When you're solving a trig problem and it has related angles in it, now a related angle is just an angle that is not acute. So you need to think about what the acute related angle would be and then think about what the quadrant you're in, and it might change the sign of it. When you're working with relate angles and exact values, my tip is just to go one step at a time. First work out what the related angle would be and the sign of that, then think through your exact values. Now you might have memorised the sine, cos and tan of 30, 45 degrees and 60 degrees. Fantastic. If you have, you've got those answers at your fingertips. If you haven't, your formula sheet has these two triangles written on it. So you can always refer to this if you want to work out 30, 60 or 45, sine, cos or tan. It's got those ratios on it. Okay. So what do we do with tan 240? Well, we need to think about the related angle. The easiest way to do that is to think, what is 240 in terms of being 180 minus something, 180 plus something, 360 minus something, okay? And tan of 240 is the same as 180 plus 60. So I've just written it in a different form. Now that gives me the related angle. I'd probably normally do that step in my head, but writing this down makes it really nice and simple. So what that tells me is that tan 240 and tan 60 are practically the same. The only difference would be that you need to think about whether it's positive or negative, because depending on the quadrant, you'll need to think that through. So we need to think all stations to central. Now what I do is I write down tan 240, that's basically a lot like tan 60, except it might have a negative here, and then I'll have a think about whether or not it does after I've written that down. So I think, all right, tan 240, we're down here in the third quadrant. Yep, tan is positive there. So tan of 60 is positive and tan 240 is also positive. So they're actually the same, they're the exact same. So this doesn't need a negative in front of it, but I did think about whether it might. Now I need to know the exact value of tan 60. Now if you memorise it, that's awesome. Okay, it's root 3, but if you can't remember it, then go over to your triangle on your formula sheet and say, here's 60 degrees here, tan of it would be opposite over adjacent, root 3 over 1, which is just root 3, and finished. All right, for this next one, you've got a few choices here. You can work with sec and then convert it to what you know about cos later, or you could work out from your exact values of cos what the exact value of sec would be. That's probably simpler in a way. We'll do it both ways so that you can see. All right, first step, what quadrant is it in? 135 is up here, isn't it? So that's the same as sec of 180 minus 45 degrees, isn't it? And that gives me the related angle. We're like 45 degrees here. It's very, very similar. We've just got to consider if it might be positive or negative because it's in a different quadrant. So at that point you can write down, okay, that's really a lot like sec 45 degrees. I leave a little space here so that I can consider whether I'm going to need a negative or not. Now we're in the second quadrant. Is sec positive or negative there? Well, sec is the inverse ratio of cos. And cos is negative there. So if cos is negative, sec will be negative. Okay? Now those inverse ratios, they're just each other flipped upside down like a fraction. The sign doesn't change, the positive negative out the front. So we know this is that sec 45 and sec 135 are virtually the same, except sec 35 will be negative, okay, because it's related to cos, and it's in the second quadrant. So it's going to be just like sec 45, except we have to make the negative version of it, okay? Now, what to do next? Well, one person might, let's use a couple of different colours. One person might say, all right, from there I'm going to say that's minus 1 over cos of 45, okay? So I just changed sec to 1 over cos. And then you might say, all right, what is cos of 45? Now you'll either remember it's 1 over root 2, or you'll look over at your drawing here and go, it's adjacent over hypotenuse, 1 over root 2. Now, it always looks really awkward when you have a fraction over a fraction, or a fraction within a fraction. If you have that situation and you get all confused, write it out like this, minus 1 divided by 1 over root 2, and then recall that when you're dividing by a fraction, you times and flip. So that changes to minus 1 times, flip that upside down and you get root 2 over 1, let's just call it root 2, And that gives you minus 1 times root 2, which is minus root 2. Okay, now a little bit of a process there, but we got there. How else could you do it? Well, from this point here, we could also say, all right, if I know, and you might write this as sort of separate, like over on the side, so the examiner can still see it's part of the same thing, but it's a separate bit of working. If cos of 45 equals 1 over root 2, then sec 45, which is its reciprocal, is the flipper of that. The reciprocal or the multiplicative inverse, they all mean the same thing. Flip it upside down and you get root 2 over 1, which is just root 2, isn't it? So at that point, if I've done that bit of working over there, and I'd probably put it in a little box to show that's what I was thinking, make sure it's right near your question so they can see it, then negative sec 45, well if sec 45 is root 2, negative sec 45 is negative root 2. Now see how that method was actually a lot easier, all right? Now, but if you've started down this path and you're here, don't worry, don't say, oh, I've done it the clunky way, just keep on going, you'll get your answer, okay? But there's often a quicker way, and thinking through that the reciprocal things you can just flip the fraction is a really good tip.